सो इन दिस क्वेश्चंस इस वीडियो में हम कुछ क्वेश्चंस देख रहे हैं। प्रेशर और हाइट में क्या रिलेशन है, हाउ प्रेशर इज चेंजिंग विथ हाइट। तो जैसे कि हम गॉज प्रेशर एंड एवरीथिंग हम पिछले वीडियोज में देख चुके हैं, तो अभी जरा इसको समझते हैं। तो इट इज़ गिवन दैट डेंसिटी एट सी लेवल इज दिस मच एंड अकॉर्डिंग टू क्वेश्चन इट इज़ नॉट चेंज जनरली। तो चेंज करता है, जैसे जैसे आप एटमॉस्फेयर में ऊपर जाएंगे डेंसिटी विल चेंज, ये कम होता जाता है। बट अकॉर्डिंग टू दिस क्वेश्चंस इट इज़ रिमेन सेम। तो अगर कम है तो मान लेते हैं कि जो ऊपर का लेवल है पी नॉट, ये कहीं ना कहीं तो जाके जीरो होगा, एटमॉस्फेरिक प्रेशर सबसे ऊपर, और यहाँ पे प्रेशर दिया हुआ है इट इज सो एट सी लेवल हम प्रेशर जानते हैं कि वो अराउंड इट इज़ 1.13 इंटू 10⁵ पास्कल होती है, दैट्स वी नो। So the pressure, this pressure should be equal to rho g h. Clear? So h will be p by rho g. So p is how much? It is 1.1. I'm taking for sake of calculation. Upon rho is 1.29 and h is, sorry, h तो इधर है, it is 9.8, or we may take it as 10 for calculations, for easy calculation. So it will be approximately, we will cancel this and it will coming to be 10⁴ meter, or it is 10,000 meter, or it is 10 kilometer. So answer will be 10 kilometer approximately. Now in this questions, it is about in ocean at 1000 meter depth, what is the absolute pressure? So if it is at 1000 meter depth, it means it is like 1000 meter. There is pressure P naught and there is pressure P. So the pressure P will be P naught plus rho g h. P naught we already know, it is given in this question 7. It is 10⁻³ kg per meter cube, 1.023. Sorry, it is 1.13 into 10⁵ Pascal, plus what is rho, that's given, it is rho. It is 1.03 into 10⁵, and g we will take, we can take 10. We should take 9.8, but because in this question it is given 10, so we are taking it 10. And what is h? H is 1000 meter. So that we will put 1000 meter. So the final pressure will be 1.13 into 10⁵ plus how much it is? 1.03 into 10⁵, and it is 4. So it will be around, or it will be 1.13 10⁵ plus 103 into 10⁵, or it is around 104.13 into 10⁵ Pascal. So the pressure will be this much. I hope it is clear. So it is the pressure, it is the absolute pressure at this depth. So what is the gauge pressure? So gauge pressure means the change in pressure, what extra pressure it exerted. So that will be, if we are interested in finding the gauge pressure, the gauge pressure will be gauge pressure will be the extra pressure, that will be rho GH, and rho G we just find out 103. I'm writing it again. For G I'm taking 10 and it is 1000. So if we look at this, so 103 into 10 to the power 3, 4 and 3, it is 7, or we may take it as 103 into 10 to the power 5. So it is around this much Pascal, and it is, for general knowledge I'm just telling, it is around 103 atm. So that means huge pressure it is. So we cannot sustain at this pressure. So it is 103 atm. We already discussed all this in our previous lecture. Now in the next part, it is about how much force is acting on a window, that which is 20 centimeter into 20 centimeter in submarine or something. So in that case, the force will be this pressure, which is 103 into 10 to the power 5 Pascal into the area, which is 20 into 10 to the power minus 2 into 20 into 10 to the power minus 2. So it is 103 into 400 into 10 to the power minus 4 into 10 to the power 5. So it will be 10. So it will be 103 into 400 into 10 Pascal. Sorry, Newton. So after solving, it is 41200 Newton. So this is small, even this is small, 20 centimeter into 20 centimeter, which is not very large, and this small window will experience a force of this 41200. It means 41,200 Newton. That's too much. Now we'll see these questions. In this question, there are three types of liquid: rho 1, rho 2, and rho 3. I am talking about densities, are placed in this U-tube kind of thing. So rho 1 is larger than rho 2. Rho 1 is larger than rho 2, and rho 2 is larger than rho 3. It means pressure at this point will be larger than pressure at this point. I'm supposing it as P2. So if we take this liquid like this, so this pressure will exert a force on this liquid towards right, and this pressure will exert a force on this liquid towards left. So it will be P1 into area. This will be P2 into area. So it means from there we can easily say that area means area of this cross section I'm taking. So P1A minus P2A is a positive quantity. It means what? This liquid is moving rightward. So U2 is accelerating rightward. It indicates U2 is accelerating rightward. So in this particular question, there is a tank of a square cross section 2 meter into 2 meter, and height is 2.5 meters. So I am taking this as a cross sections right now. So it is vertical cross section. This length I am supposing 2.5 meter, and this as 2 meter. Clear? So at this height, depth I mean, if you take a length like this, so it is of dh. So dh into 2 meter, right? So the force will be force on dh element will be rho gh into 2 meter into dh. Why it is? Because area of this element is 2 into dh and it is rho gh. So let's call it df because there is a dh. So now we can integrate. On integrating, force will be rho g to h dh, and from 0 to 2.5 meter. So it is 2 rho g h square by 2, 0 to 2.5. So 2 will be outside, so it is rho g 2.5 square. So it will be how much? We can calculate. So its answer will be 6.25 into 10 power 4 Newton. That means the force. We can do this question with another way. If we take the pressure at the center and then we multiply that pressure with this area, we will also get the same answer. So you will try, and if you are getting answer, please let me know. Now, what will be the pressure at the bottom? So the bottom one too very easy. It is will be force on the bottom. The next part of the question, force on the bottom will be easier, relatively easier part. So that force will be rho g h into the total area, which will be 2 into 2. So rho is what? 10 power 3, g is what? 10, and h is how much? 2.5 into 4. 10 to the power 4 into 10. So it is 10 to the power 5 Newton. Hopefully it is clear. In our next video, we will see few more questions.